Hello. Today we are going to see how we can implement switch case in Python. So there is no inherent support for switch case as a control structure in Python, the way it is for if else or while and for loop. Many other programming languages, if you have come from C, C++ background, you might have seen switch case as a control structure. So what happens here is that a variable X, the value is matched for that variable based on the cases, and then a set of statements are executed. So if the value for the variable X is 1, this case is matched and all the statements inside this case gets executed. Same goes for if the value is 2, then you have this bunch of statements being executed by the program. And in case the value does not match any of these cases, then it goes to the default section and executes the statement declared defined here. Now, how we can do this in Python? So I'll park this for now. We'll move on and understand how functions behave in Python, and we'll get back to switch case. Functions in Python are first-class citizens. What I mean by that? It means that you can assign a function to a variable, and you can pass a function as an argument to another function, because at the end, everything in Python is an object. Let me create a function here. So I create add function, which pass two arguments. Let's say it takes two arguments, X and Y, and it returns sum of those two values. Okay, and then I can invoke this function like this. I say result is equal to, and I call the function, and I pass it some values, and I print the result. Let me run that again. So I do Python 3, fun example, and I get the result. Okay, what is really happening behind the scene? As I said, everything in Python is an object. So when you are creating a function, that function is also created as an object in memory. So you have an object in memory, that function object, and there is a reference to it. So when you are creating an object in memory, the reference to that object is called add_fun. This is same as any other variable that you create in Python. That variable, the value of that variable is stored as an object, and the identifier is more a reference to that object. The difference over here is that add fun is a callable. So if I create some other object, let's say num equals to 10, right? This is going to be an integer object in memory. Num is the identifier having the reference of that object, but that object is not callable. To understand this, if you go to your Python REPL and import it from fun example, so I'll just do from fun_example, import num, add_fun. And I say callable, and I pass num. It's going to return false, because num is an object which cannot be called, which you cannot invoke it. You cannot do something like this, right? So num is not callable. Whereas the other function that I've created, add_fun, it is returning true because I can invoke the function by passing arguments to it. Okay, so it's callable. Both num and add_fun are just identifiers, and they are pointing to different types of objects. Num is pointing to an integer object which is not callable. Add_fun is pointing to a function object, and function objects are callable. The way, if you're having num and you can create num1 equals to num, where you are just assigning the reference of the same object to another identifier, you can do the same thing for add fun. So I call my fun equals to add_fun. Okay, and now given that I'm having another reference which is pointing to same object, so I'm having the same object, and it is also being pointed by another reference. This time it is called my fun. I can access this reference my fun to get to the same object, which is the callable function. So instead of add fun, I can write my fun, and I'll run my program now. You see, I get the same results. I have not defined any my fun as a function. Function using def keyword, I have created an add function. But as I explained, functions are first-class citizens in Python. You can assign the reference of the function to a variable. So I'm assigning that function to a variable and then invoking the function. I'll just clean this. Another example, I'm creating a function ONE1 and it returns string 1. I'm creating another function 2 and it returns string 2. I can create variable and assign value to it. So I can create a variable, I call it f underscore 1 and assign function 1 to it, f underscore 2 and assign function 2 to it. Please note that I'm not invoking the function. If I do print of f1 and print of f2, it is going to give us the reference to the function object, the memory location of those function objects. Okay, it is not storing the value ONE1 because I'm not invoking the function like this. The moment I invoke it, if you see here now, the difference is that here I'm invoking the function, I'm calling the function. The moment I call the function, this code gets executed and the value returned by this function is stored in variable f1. That's why you see the value here. Whereas in the other case, I'm just assigning the reference of the function. I'm not invoking the function. That's why f2 is a reference to that function. If I want to invoke f2, I can invoke it like this. So if I do like this, this is going to invoke f2. So in this time, I'm just storing f1 and f2 over here, but here I'm going to invoke f2. So now if I run my program, you will see the function has been invoked and whatever value the function returns, you can see here. I can add these two variables to a list also. So if I want to create a list, let's say function list, I can add two functions inside it, 1, 2. This is how I can add two functions to a list. The way I iterate any list, I can iterate this list also for f in f underscore list. I'll just do a print of f and invoke the function, right? So this is going to invoke both the functions and you see the output over here. I can convert this list into a dictionary. So I call it as fdict. And here I'll do 1 as the key and the value is the reference to the function. Similarly, 2 is the key and value is reference to the function. I'll ask the user to enter a number, x equals to input and enter a number. Input returns a string. I have to cast it into an integer value. And then I'll say f equals to fdict and pass the key to it. What is going to happen over here is that if user enters 1, in that case, the key will be 1. And as a normal dictionary, when you provide it a key, it returns you the value. So you get the value and value will be referenced to function 1. Then I can invoke the function. So I say print f and the function name. Okay. Now I'll run the program, enter a number. I'll enter 2. Enter a number, I'll enter 1, right? So this is working like switch case. If you see, when I'm entering 1, it figures out the code to be executed as part of that particular choice and it executes that. Challenge here is if I enter some other number, let's say 100, it doesn't know what to do in case of default. So it throws the key error. Now we'll handle this. I'll create a default function and it will return invalid choice. And here what I'll do is, instead of using this syntax to get the value from dictionary, I'll use the .get method. What .get does is if the key is present in the dictionary, then it returns the value associated with the key. Otherwise it returns a default value. So in place of default value, I'm going to return my default func. And now if I run this program and I'll enter a number like 100, it's going to tell me it's an invalid choice. If I enter a number 1, it is going to invoke the function, the code defined inside that. Now, connecting the dots back to the syntax that we have seen earlier, what I've done is this exact switch case I've implemented. Given that switch case syntax like this is not supported in Python, what I have done, X is my input variable. So I'm taking X input from user, which you can see over here. And then I'm placing the code. So these are the keys are my cases. So in the dictionary, what all keys I have created, these are the cases that I want to handle. And whatever code I want to execute as part of the case, once the case is matched, I'm placing that code inside function and assigning functions as values to the keys. That's how I implement switch case in Python.